In this video, we look at this integral, the MIT Integration B question of 2025 regular season. So let's dive right into this integral. So we can start off by really looking at this integrand. So this is the cosine of the cosecant inverse of x, right? So cosecant inverse of x. Cosecant inverse of x can also be written as sine inverse of 1 over x, right? So if we know this, then we can plug this into our integral. So our integral here is going to be I is going to be the integral of x squared cosine of, instead of cosecant inverse of x, I'm going to replace that with sine inverse of 1 over x dx. And we have to do another substitution. So here I'm going to prove an identity. So we can let x here to be equal to sine of theta, right? So if x is equal to sine of theta, that means that theta is equal to the sine inverse or the arcsine of x, right? So knowing this, we can take cosine on both sides of this. Taking cosine on both sides is going to be the cosine of theta to be equal to the cosine of the sine inverse of x. So it means if I am able to express cosine of theta in terms of x, that can be written as the cosine of the sine inverse of x, right? So from here, from the Pythagorean identities, we know that sine square of theta plus the cosine square of theta is equals to 1. So that implies that the cosine square of theta is equals to 1 minus the sine square of theta. So that implies the cosine of theta is equals to the square root of 1 minus sine square of theta. Right, but what is sine of theta? Sine of theta is equals to x, so we can just replace that here. So that implies that the cosine of theta is equals to the square root of 1 minus sine square theta. Sine theta is x, so sine square theta is x squared. So cosine of theta can be expressed as the square root of 1 minus x squared. But we know that cosine of theta is equal to the cosine of the sine inverse of x. So in that case, we can just express this one as the cosine of the sine inverse of x. This is equal to the square root of 1 minus x squared, because the cosine of theta is the same as the cos of the sine inverse of x. So this is how cosine of the sine inverse of x can be expressed, right? So we know that the cosine of the sine inverse of x is equal to the square root of 1 minus x squared. So that implies that the cosine of the sine inverse of 1 over x, this is equal to the square root of 1 minus 1 over x all squared. And that is equal to the square root of 1 minus 1 over x squared. So that is the square root of x squared minus 1 all over x squared, which is equal to the square root of x squared minus 1 all over x. So this is how the cosine of the sine inverse of 1 over x can be expressed in terms of x. So we can just plug that into our integral and simplify the integral out. So our integral is equal to the integral of x squared times the cosine of the sine inverse of 1 over x, which I can just replace with this guy here, dx. And this one will cancel one of it at the top, and leaving x to be equal to the integral of the square root of x squared minus 1 times x dx. Now we can do a u sub. So doing a u sub, we are going to let u to be equal to x squared minus 1. So that means that du is going to be 2x dx. So we can divide by 2, divide by 2. So that means that 1/2 du is equals to x dx. So in place of x dx in our integral, we can just replace that with 1/2 du. So our integral is now I to be equal to the integral. This is the square root of u times 1/2 du, which is 1/2 in front, the integral of u raised to the power half du. And that is equals to 1/2 u raised to the power 1/2 plus 1 over 1/2 plus 1. and that is equal to what? So that is equal to 1/2 multiplied by this one is 3 over 2, so the reciprocal of that is 2 over 3 u raised to the power 3 over 2 plus the constant of integration. So I is going to be equal to, this cancels that is 1/3 u raised to the power 3 over 2 plus c. But what is u? U is x squared minus 1. So just replace that. So I is going to be equal to 1/3 x squared minus 1, which is our u, raised to the power 3 over 2 plus the constant of integration. So therefore, if we integrate the x squared of the cosine of the cosecant inverse of x dx, this one evaluates to 1/3 x squared minus 1 raised to the power 3 over 2 plus the constant of integration. So this one is the answer to our integral. So that is how I can solve it. If you know a faster and easier way to solve this, please leave the comment in the comment section and let me know what you think. Anyway, that's it. If you find this video helpful, make sure to give me a thumbs up and subscribe to my channel for more content. I thank you so much, and I'll see you in the next one. Bye bye.